Yes, we're on. So thank you, Professor Haghdoost, for joining me today. You are the project coordinator of the project CORNET, if I'm not mistaken. Could you please introduce us your project?
Yeah, for sure. And thank you very much for inviting me to and give me this opportunity to present my project. So the CORNET project is on the subject of cancer carcinogenesis and its effect by radiation. So actually exploring the role of microenvironment after low dose exposure for colon cancerogenesis and radiation risk is the full name of the CORNET. And it started some days ago, the 1st of September 2025, and will finish at the end of 2028, so 40 months. So just give you a very short introduction. First of all, colon cancer caused approximately 1 million deaths each year, and it's almost 1.9 million new cases per year. And it's strongly related to lifestyles and environmental factors, including actually exposure to ionizing radiation. And very interesting and very important is if we look at the A-bomb survival cohort, Japanese A-bomb survival, you can find that colon cancer is the second most common cancer in this cohort. Um, the goal of the CORNET is to explore how low dose of ionizing radiation considering the non-mutational process, focusing on the tissue microenvironment can contribute to carcinogenesis, colon carcinogenesis. And the projects have 5 work packages. So number 1 is dedicated to coordination by myself representing University of Caen, Normandy, France. We have also work package number 2, which is very focused on carcinogenesis and exposure of the a mouse model that I will describe very soon, coordinated by the people from ASNR. I will present them very soon to you. VP3, going more in the mechanistic point of view, and it's represented by the Simone Mortel from BFS Germany. We have also a work package dedicated to system biology and risk modeling of the biological based risk. This is also by the BFS group, and we have an education and training by our Italian members. First of all, University of Caen in Normandy, we are affiliated entity to CEA, which is the Commissariat Atomic Energy in France. So I am representing the university as a coordinator, and I have also help from my colleague, Karine Laurent, who is the radiation biologist here, and we are doing both coordination as well as some of the analysis planned in the project. ASNR, who are responsible for the VP2, represented by the Guillaume Vares, who is the work package leader of the VP2, and working with the model of colorectal cancer. So they have a mouse model they can expose to. He is a radiation biologist, Dr. Dmitry Kolokov, as well as Imran Gerali. Dimitri is very focused on low dose carcinogenesis and also other long-term effect of radiation, and Imran, researcher in the system biology. BFS, which is stand for the Federal Office of Radiation Protection in Germany, Dr. Simone Mortel is the work package leader of VP3. She is very focused on the cell communication, cell-to-cell communication process in response to radiation and how it's affected by radiation. We have also Christian Kaiser and Markus Edmuller, who are very focused on the risk modeling and mathematical based models of the risk. They are responsible for VP4. We have also a group from INSERM, University of Nantes in France. They are focusing on the human colon cancer or human digestive development. They are developmental biologists. We have also Emily, actually, who is a professor, Emily Duchels, who is professor of the digestive surgery, helping us with the materials from human colon cancer that will be tested here. So finally, we have a group from Italy, so National Research Council, Institute of the Clinical Physiology, represented by Dr. Ionica Campola, who is the leader of the work package 5, research and it's education and training. She's a researcher, and Dr. Maria Grazia Andresi, who is the head of the molecular epidemiology, and they will be very involved in the majority of the work package doing microRNA screening. So basically, I set up this work, this project based on the previous collaboration with all of them, all the people that are presented here. I have had whether by themselves directly or by their institute, we had and collaborative work within other research projects, such as harmonic projects, such as Doremi project that was successful European projects in other programs. So what this project is about, so in this project we have two important models. One is in vivo mouse model, and the second one we have two different type of maybe three different type of in vitro models. In the in vivo models is the mouse. This mouse has a specific mutations or by the genetic engineering, they have been introduced a specific mutation. We call it KPC-APC model, two different type of mutations. So they generally, spontaneously, when they receive a tamoxifen treatment, so they can produce colon cancer. So what I wanted to say here is that this model is an inducible model. It means that these mice are living normal. We gave them a dose of the tamoxifen. So then in the colon, they will produce different, let's say, types, if I can, or different grade of the colon cancers, or adenoma. So the question then is, if we add to that mouse a low dose of radiation, in this case 25 and 250 milligray, so what will be then outcome considering the number of the tumors produced on those mouse and also the size of the tumors. So basically we are looking at this effect, not considering the initiation step of the cancer. It's actually progression and promotion steps. So in this model, in this mouse model, so we irradiate them and then we keep them certain time, and then after that time points, we can eliminate or kill the mice, and then we look at the those number of the tumors produced with and without radiation, the size of the tumors, and there are many other analyses that will be done in parallel. At the same time, we are going to set up an organoid model from the mice. So we take the adenoma or the cancer that produced from in the mouse and put it in the culture and get them to grow as an organoid model. And the idea is that ASNR, responsible work package leader, will then send the different organs of these mice or different tissues, such as not only the cancer tissues, but also the normal colon as well as the blood, will be sent to the different labs within the consortium, and we do the different analysis. In the work package number 2, handled by the BFS in Germany, so they are specialists in extracellular vesicles. So they will also receive the samples from these mice. At the same time, they will also, together with the people from NOMS, the INSARM team, they will also set up the human organoid model with a very similar genetic background, so APC and KPC mutations, which is usual type of mutations in the even human colon cancer models. They are setting up this model there. So they are extracting or collecting the extracellular vesicles, and in Germany, so they will do kind of quantification and qualification of the EVs, and they will then send these EVs to different labs again within the consortium, such as to University of Caen and also to Italy for doing the proteome analysis in the EV, and as well as the microRNA in Italy, and also the other analysis that is planned within the project. So then the idea is that when the results are ready, so we send all these mechanistic biological results to the work package number 4 people. So they are working within the system biology and also modeling of this. So they are putting all these results in a model, and it gives us opportunity to have an mathematical model based on the results that we get from this analysis. And it's their specialty. So they have been working in this area for many years now. So finally, for package number 5, education and training. So basically the outcome, the results of the project will be feeded to the VP5, and we will be involved in the setting of the courses, education, and also training of the young researchers, and to communicate the results from the project. So what we expected from the project is that, number one, first we will get the answer if a low dose radiation, particularly in this case 25 and 250 milligray that we are using, have any impact, positive or negative, in colon cancer promotion and progression. And if any case is positive or negative, we will also explore the role of the cell-to-cell communication within the colon carcinogenesis, and if this cell-to-cell communication will be affected by these 2 doses of radiation. And at the same time, we will also look at if the tissue microenvironments, such as immune cells, are there, if they have a pro or anti-inflammatory environment, as well as we will also look the level of oxidative stress, and see if these tumor microenvironments can affect this carcinogenesis process and be affected by the low dose of radiation. So finally, and very important part, or not very final, but very important part, is that we have a human model, human colon cancer model coming from nuts, that we can apply some of the results that we gain from the mouse model and mouse organoid model to be applied in the human organoid model and see if we can verify some of these results on human organoid model.
Mm.
Of course, this will give us opportunity and this will improve our mechanistic knowledge underlying low dose radiation induced colon cancer induction. So that was the last uh, slide. I am available for any question.
Thank you very much. If I may ask, these results, these key results from the research, when do you expect them to
I think
retrieve?
yes, and the project is 14 months. And during the first 3 years, we will have the majority of the results. Maybe not the system biology part, because they have to wait until we produce the biological analysis and then set up them as an understandable way to explain, and then they can use it in their mathematical model.
Oh yeah, I imagine these projects are long term.
Yes.
It's very difficult to know something that soon. Wow, incredible! Thank you very much, Professor. It's been enlightening. Anything else you would like to add or summarize?
Oh, that's fine.
Thank you very much. Thank you
you.
for your time.
Thank